Welcome to the second tutorial of ANSYS 2018 series. So in the first series we have seen the analysis of a simply spotted beam in ANSYS APDL. In our second tutorial we will gonna see how we analyze a simply spotted or a beam or simply a beam in ANSYS Workbench. But before starting my video I would request you to subscribe my channel and hit the bell icon for the upcoming videos. Now first of all you have to open your ANSYS Workbench on your laptops. After opening the ANSYS Workbench, you will find a window like this. You may have find a window like this, but I just took the analysis type static structural in separate from these boxes, so you can select it from here as well. So since I am keeping my structural analysis, I will be doing the analysis of a beam here, so I will keeping the analysis type to static structural. After selecting your analysis type, when you click on this static structural, what you will be having is that you will be having a box in front of you where you will be finding different options like static structural, engineering data, geometry, model, setup, and solution and results. So first off, these are basically the steps for doing the analysis of any structure in ANSYS Workbench. So first of all, as you can see that your first step is to select your analysis type. So I have selected my analysis type as static structural. Now my second step is engineering data, but you can see that the green tick is already appeared in front of the engineering data. So the reason is that the ANSYS assigns a material which is the structural steel to all the structures you create in ANSYS Workbench defaultly. So structural steel is assigned default. We can change any material, we can change any material, but for the time being I'm going with the same material which is the structural steel. But in the upcoming lectures we will be changing these materials. We will be defining our own materials. We can define our own materials from clicking here to add the new material, then we can assign the properties of that material to define that material. But for the time being I'm going with the same material. So after clicking on selecting my engineering data, you can see that I have green tick already appeared in front of engineering data. After selecting my material, what I will be doing, I will be defining the geometry. Now for the defining the geometry, we have three different options for defining the geometry in ANSYS Workbench. One is the method which is the design modeler, and one is the space claim, and one is the import geometry. So we will be using space claim geometry in our case. We can also use design modeler, but space claim gives us a type of feelings like you can see in AutoCAD or SolidWorks. So I will be using the space claim for my current design. For the import geometry, it is also a very good option for those who can work on other applications such as the SolidWorks. You can create your model in the SolidWorks application, and then after creating the model in SolidWorks, which is a very easy application, you can simply import your model into ANSYS by using this import geometry option, and you can simply done its analysis. I will be showing you how to model any structure in the SolidWorks, and then how do we import from SolidWorks to the ANSYS. So you can see that the space claim is opened in front of me, and I will simply close this menu. So this is the ANSYS space claim where we will create the geometry of our model. The first thing you have to do after opening the space claim is to select your units. I will simply go to file and then click on this space claim options, and in this options first you would have to define your units. In default mostly you have the millimeter units, but it can be changed. So you first of all you have to verify your units, that whatever the units you wanted, you have to select those units. You can select any of the units. I am going with the same units, but like metric type, I am having my length in millimeters. I can keep in millimeters, but I am more comfortable with the millimeters. So I will simply press OK. After defining the units, the second thing you have to define is your sketch plane. So I will be sketching my model in the XY plane. So in order to define your sketching plane, you would have to click on this select a new sketch plane, and after clicking on this sketch a new plane, you would drag your mouse here in front of you. Now this is my YZ plane, this is my XY plane. So I will simply click with my mouse and I have selected my XY plane. After selecting the XY plane, will be moving to the plan view of my plane. So I am now seeing my sketch plane from the top, and now I will simply go back to my 3D mode after selecting my sketching plane. Now I am back with the in the 3D mode. So now I will be drawing my geometry. So I'm having a beam which is rectangular. So I will simply select a rectangular which is of 2 points, and I will start my rectangle from drawing from the origin. And after the origin, I simply say that my uh, beam is 2500 millimeter or 2.5 meter long, and simply I will press the tab button and I say that it is 250 millimeter or 0.25 meter in depth, and I will simply press OK. Now you can see that my beam is drawn. So you can also use the pen option to move the model in front of you. Also you can use the spin options to rotate, but now you can see that it is simply a single a plane. There is nothing is thickness. So in order to define the thickness of my beam, what I will be doing, first of all I am aligning a bit in front of me, so like this. After aligning like this, I will use a command which is pull. You will simply press P from your keyboard, and when you will keep drag your mouse in the face of your structure, you can see that two arrows appear. One arrow is asking you to move backward and one is asking to the forward. I simply click on the face and I will drag my arrow in the forward direction. After that I can write the thickness of beam. For example, I say that thickness of my beam is 200 millimeter. I will be writing the thickness of my beam, and you can see that my beam model is created with having a thickness of 200 millimeter, length of 2500 millimeter, and a depth of 250 millimeter. So I will be applying basically point load on my beam. So as you know that we have in FEM analysis, what we do, we apply loads on the elements. Basically we divide our structure into a number of elements and then we study its behavior, or we apply load directly at the nodes. So for my model I am applying a point load on the center. So what I wanted that I just uh, divide my top surface of the beam into different patches, and at the center a little patch I can apply a point load on that little patch. So what I will do, I will simply create a patch, a small patch on this top surface of my beam. So if I make some zoom, and now it's more visible to me. So now what I will do, I will simply use a command which is the split command, and I will simply click on this face. After clicking on this face, you can see that my patch it's asking me what is the length of the patch. So what I will do, I will divide my top surface into three parts, so that I have a central part which will be central element. Basically I will be dividing my top surface into three elements, and the central element will be very small where I will apply the point load. Okay, so I want that since I have a 2500 millimeter total length, so I will be having the first patch equal to 1200 millimeter, and I will simply press OK. Now again I will simply select this face, and again I will be having a patch of, for example, 100 millimeter. So sorry, I just wrote the percentage what I wanted a patch of 100 millimeter, so I will simply press 100 and now my patch is created. So one element, second element and the third element. So I wanted my point load to be at the center. So basically the geometry is now my defined. Now what you have to do, you can also save your geometry from going to file and then save your file. But ANSYS directly, if you wanted you use this geometry in your future products, you can save. But I, for the time being, I am just leaving this as it is, and I am simply close my space claim. After closing my space claim, but you can see that my geometry is defined, I have defined my engineer data, I have defined my analysis type. So 3 steps are done. Now it's the time for the first step. Now I will simply click on the ANSYS model generator. Now as you can see that my ANSYS model generator is open in front of me, and I am seeing nothing in my plane. First of all, we will just wait for some seconds. Since ANSYS Workbench is a heavy software, so it is lagging. So we will just simply wait for some time, for a few seconds, and a geometry will be appearing in front of you. You can see that the my status is almost completed. So now you can see that my geometry which we drawn in the space claim is now appeared in front of me in the ANSYS mechanical modeler. So after going to here, now I have just created my model, its geometry is done, its coordinate system is done. Now we'll simply go to mesh. So first of all, in the mesh you will go to mesh control. You can see the menu has appeared here. Simply go to the mesh control, and in the mesh control I will simply control the sizing. So sizing, for the sizing you can see a yellow box appearing at the geometry section. So I will simply click on it and apply. How to apply? Now I wanted this mesh sizing to be on the whole body. So what I will be doing, I will select, go to this menu, and I will select the body, control B option, and I will select the whole body with this option and will simply apply. Now by mesh, basically my structure is now meshed. You can see that my structure is now turned into blue. So it means that my body has been meshed and the yellow box is disappeared. And also you can see that green tick is appeared, so it means that my meshing is done. You can also control the meshing method as well, but for the time being I will be not going to that. Since my meshing is done, I have defined my mesh size. You can also go to mesh edit, but we will also see these things, but in not in this lecture. We will see this in detail in upcoming lectures. So now what I will be doing, I will simply go to mesh and simply click on generate mesh. So basically giving an error that mesh control is not associated. So what I will be doing is mesh and the automatic method. So basically I have to select the geometry for this. So what I will be doing, I will simply go to this and select this body and apply. Now I will go to automatic method, and now basically my mesh is done, generated mesh. So now you can see that it is meshing, and now our error is removed and meshing is completed. After the meshing, what we will be doing, we will go to analysis setting. After going to analysis setting, now you can see that my menu here is changed. First of all, I will assign the supports to my beam structure. So I am assuming that my beam is fixed at both ends. So I will simply click on the fixed support, and I am having the support now on which geometry I will be applying my fixed support. So I am selecting this face so that I can apply the fixed support. Now my fixed support is applied to this first face. Now I will be rotating my beam section, if you can see that, to select my second. face. So now what I will be doing, I will go to sports, fixed sport. For the fixed sport 2, I will simply select this 6 and apply. To apply to which I will be simply selecting this. I will simply let me move it like this, and this is my first, and this will be my second. Selecting, I will simply click on the face and I will simply select this face and apply. Okay, so now my second fixed spot is also applied. So let me rotate it so that I am having a so now you can see that I have a beam which this end is fixed, and a beam whose this end is also fixed. So now I have assigned the fixed spot. Now I will be assigning the loads. Now how I will be assigning the loads. Since I have said that I have only a point load which is applied at the center, so I will go to load and I am applying load in case of force. And how I will apply the force, I will apply the first of all I will select the geometry. So I want to apply the force here. Select this and click on apply. After going to this, now I wanted to define my force with the help of components. So will be applying the force in the y component. So I wanted to apply a load of 25 kilonewton, so minus 25,000, so that I can apply the load in normal direction. Simply press OK, and now I have applied my load on the structure. So if I just rotate it, you can just observe. So this is my load is applied, you can see. So after applying the load, I am all done. So I will simply go to now solution, and for the solution I will simply click on the solve. And when I click on the solve, you can see that it is solving my mathematical model, and it will just take within 1 minute it will be completed. So you can see that my analysis is almost completed, and you can see that nothing has appeared in front of you. So total time is taken is 7 seconds, but you see nothing changes in my section. So what you will do, basically your analysis is done. Now what you will do, if you click on solution, now you have different options. For example, I wanted total deformation of my beam, I wanted the equivalent stress, I wanted the normal stress, and I wanted the shear stresses. So I just wanted these 6 results. You can simply go to again simple, and I will simply go to solve. Again I will click on solve, and after solving, now you can see that this is my total deformation of my beam. This is the equivalent stress, this is the normal stress, this is my shear stress. You can also see that from your observation that what we studied, that when we apply load at the beam, what happens to the beam generates tension in the downward direction. In its lower portion, basically it has tension, and its upper portion it has compression. So you can also observe from that in the upper portion we have the stresses which are negative. So you can see that compression in the top portion and tension in the bottom portion. Also you can see this deformation as well, your deformation, and we have a very little deformation. And one is the very important thing regarding the yielding, which tells you about the regarding the yielding of your material, is a von Mises stresses or equivalent stress. You can also check the results. So this is your stresses values, and your stresses are in megapascal. So that was all about the analysis of a beam whose both ends are fixed in ANSYS Workbench. I hope you would have understand all the procedure for doing the analysis. If you have any kind of queries, you can comment below. And if you like this video, then subscribe my channel and hit the bell icon, because I will be uploading a number of videos, a number of tutorials for ANSYS Workbench and ANSYS APDL. So stay tuned.